Let's now see the relation between number of antisymmetric and reflexive relations. Okay, so I don't know, again the base is same. We are talking about relations on a set A with n elements always. So I don't know whether this diagram is right or wrong, but I'll just justify if it is right, otherwise I'll just redraw it again. Okay, so now let us say this is number of antisymmetric, set of all antisymmetric relations A, and this is set of all reflexive relations R. Okay, and the outer rectangle is set of all relations possible U. And what are the things that we already know? N of A. So n of A is going to be number of antisymmetric relations. It is 2 power n into 3 power n into n minus 1 by 2. This we already know it. And then number of reflexive relations, we already know this, right? We have to include all the diagonal elements, and from the non-diagonal elements we have two cases, isn't it? 2 power n into n minus 1, right? And then we know the total number of relations possible, n of u is going to be 2 power n square, right? And if you have to answer the remaining questions, we should know what about this intersection area. So first of all, let's see whether this diagram is right or wrong. So let us say this is region 1, region 2, region 3 and region 4. So let's justify it by giving some examples, some relations which will fall in each region. Now talk about region 1, R1. So this is nothing but set of all relations which are antisymmetric but not reflexive. So what are the relations that are antisymmetric but not reflexive? If a relation has to be antisymmetric but not reflexive, to get the relations which are antisymmetric but not reflexive, you can actually just discard or don't include one diagonal element, that is enough, and then see that the resulting relation is antisymmetric as well. For example, you can, the simplest one is this 1 comma 2, that is enough, right? Or even the empty set is also an example, right? If you take an empty set, that is going to be antisymmetric but not reflexive because it does not contain all the diagonal elements. Or if you want some other example, 1 comma 2 also will do, because it is simply not containing all the diagonal elements, therefore it will not be reflexive, but it is antisymmetric because it has only x comma y but not y comma x. Got it? Now what about R2? The number of relations, or at least give me one example which is both antisymmetric as well as reflexive. So if you want something which is reflexive, definitely we have no other escape, you have to include all the diagonal elements, right? And now this is the smallest relation which is reflexive, and it also happens to be antisymmetric. It is a reflexive relation, and moreover it happens to be antisymmetric as well, right? So this might be an example which is both reflexive and antisymmetric. Or if you want more examples, along with this you can add one more element or few other elements without adding x comma y and y comma x both. Got it? Fine, you can frame more examples if you want. Now R3. So I want to find out the relations for the region 3. Now what is region 3? They are reflexive but not antisymmetric. So if it has to be reflexive, we cannot escape this, we have to include all the diagonal elements. Yes, after including the diagonal elements, I just want to add some more elements in order to make it not antisymmetric. So for that reason I'll just add 2 elements just to make it not antisymmetric, right? At least we have to add 2 elements of type x comma y and y comma x in such a way that this will actually be kind of this because of these two we are not going to have a relation which is antisymmetric, right? It will violate the principle. What is it? X comma y and y comma x both should not be present in antisymmetric. So R1, R2, R3 are justified. Now can you justify region number 4 as well? Okay, so how to find out whether something exists in region number 4 or not? So can you find out any relation which is neither reflexive nor antisymmetric? Yes, so you can simply put 2 comma 1 and 1 comma 2. It is definitely not reflexive because it is not containing diagonal elements, all the diagonal elements, and it is not antisymmetric because it contains x comma y and y comma x. Therefore all the regions are justifiable. Now in order to answer the other questions like how many number of relations are there which are antisymmetric but not reflexive or something like this, all these questions you have to solve for region 2. If you can find out the cardinality of region 2, then you can answer many questions on this problem, right? So what could be region 2? Now it is nothing but the number of relations which are both antisymmetric as well as reflexive. So how many such relations can you get? See this. We know that A cross A is going to have two types of elements. Some elements are diagonal and some elements are non-diagonal, right? Now if you have to make this if you have to find a relation which is both reflexive as well as antisymmetric, you should definitely include all the diagonal elements in that, otherwise it is not going to be reflexive. So for these diagonal elements I don't have any other choice, I have to include them, which means I have only one choice. So nothing, I am not going to write 2 into 2 into like that, only one choice, I have to include all of them, right? And now going towards this these non-diagonal elements, you have to pair them up, and each pair is going to give us 3 choices. Why? You can either include the first element or second element or none of them. That is how each element is going to give us 3 choices, right? Okay, so how many non-diagonal pairs will be there? N into n minus 1 by 2. So each one is going to take 3 choices, 3 into 3 into 3 into so on, n into n minus 1 by 2 times. Therefore the number of relations which we can form which are both antisymmetric and reflexive is going to be 3 power n into n minus 1 by 2. Got it? So we know now n of A intersection R is equal to 3 power n into n minus 1 by 2. This is clear. Okay, now using these 4 we can derive any question, right? If they are asking about n of A union R, which means find the number of relations on A which are both antisymmetric and reflexive, it is nothing but, from this diagram we can see that it is n of A plus n of R minus n of A intersection R. Similarly they'll ask, if the question is about number of antisymmetric relations which are not reflexive, then they are talking about region 1, so which is nothing but n of A minus n of A intersection R, right? If they are talking about number of relations which are reflexive but not antisymmetric, they are talking about n of R minus A, which is n of R minus n of A intersection R. Got it? Or if they are talking about region 4, which means number of relations which are neither reflexive nor antisymmetric, then they are talking about n of R union A complement, which is nothing but n of U minus n of R union A, right? So which means you have to find out all the relations which are in region 4. So you can substitute those numbers and you can find out, and in place of n they will give you some number, like they might talk about a set containing 4 elements or something like this. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.